Hi folks, welcome to this short video on cardiac values of the heart. As you can see by looking at the screen, there are three key terms that you need to know definitions of, and you need to know definitions of these three and how they relate to each other. Number one is cardiac output. Okay, so what is the definition of cardiac output? And there is the definition there. It is the volume of blood pumped out of the heart per minute. Now that is the key bit there. Volume of blood pumped out of the heart per minute. Now what I'd also say is this. If you want to be a bit flash, okay, and you don't want to say pumped out of the heart, there is something else you can say. Instead of saying out of the heart, if you want to be technically more accurate, it's out of the left ventricle, because that is the chamber that is pumping blood around the body. Remember, the right ventricle is going to pump blood to the lungs. That's the blood that's going to pick up oxygen, get rid of its CO2, and then come back to the heart to then be sent around the body. We're not interested in that in cardiac output. Cardiac output is the volume of blood pumped out of the left ventricle per minute. But if you panic and you think, I can't remember which ventricle it is, doesn't matter. You are still going to get the mark for saying the volume of blood pumped out of the heart per minute. But you've got to get per minute for cardiac output. Okay, so that moves on to stroke volume, and here's the definition of that. Now, as you can immediately see, that is very, very similar. But this time it's the volume of blood pumped out of the heart per beat. Okay, so this is one contraction of the heart, how much blood is being ejected out of that heart in a single contraction. Similarly, equally, if you want to be really flash again, you can do exactly what we've done there. If you don't want to say the heart, you can say out of the left ventricle. You've got to get them the right way around. Right, cardiac output, the volume of blood pumped out of the heart per minute. Stroke volume, the volume of blood pumped out of the heart per beat. And finally, dead straightforward, nothing tricky here. Heart rate is simply the number of beats per minute. Okay, dead straightforward. 60, heart rate of 60, and what the units we like to use are for heart rate. Let me just get my pen. BPM, beats per minute. Okay, now that's dead straightforward. You need to know those definitions. There's no two ways around it. Okay, what they sometimes like to ask is the relationship between the three. Okay, so let's have a quick look at the relationship between the three. And there is the very simple equation that links the three, sorry, beg your pardon. So, cardiac output equals stroke volume times multiplied by heart rate, okay? The question often comes up, provide a definition of cardiac output and stroke volume. We've never seen a question on defining heart rate because it's dead straightforward, the number of times your heart beats in a minute. So what is the definition of cardiac output? What is the definition of stroke volume? And what is the relationship between them? Now, the hardest part is they sometimes don't mention heart rate, and you're going, well, the relationship between stroke volume and cardiac output, I need to mention heart rate as well. Brilliant, do that. The relationship is cardiac output equals stroke volume multiplied by heart rate. Now, to give you a typical example of what that might be, at rest, your stroke volume, so the amount of blood pumped out of the heart per beat, typically is around about, on a normal average size heart, 70 millilitres. About a small mouthful of fluid, very small mouthful of fluid. Okay, 70 millilitres of blood. Okay, what is a typical resting heart rate? Well, we say anything between 60 and 80. I think the average is still in the nation classified as around about 72 beats per minute. So, those mathematicians or those with a calculator handy will be able to do 70 times 72. Fortunately, I've already done it before I start recording this because my brain doesn't do those kind of maths, not a chance. Okay, so the answer to that would be 5,040 millilitres. And remember, what is cardiac output? The volume of blood pumped out of the heart per minute. So in other words, 5,040 millilitres per minute. Now remember, there's 1,000 millilitres in a litre, so we could write that even simpler as 5.04 litres per minute. And that's about right. If you read most textbooks, at rest, whilst you are sitting there watching this, your heart will be pumping out around about 5, just a little bit over, 5 litres of blood per minute. Because each time your heart contracts and beats, it pumps out 70 millilitres, and the average will be about 7, average heart rate is 72 beats per minute. Obviously, if you know that your heart rate is 60 beats a minute, you could do a quick calculation yourself, you'd think, but the problem is, we don't know what that is. The only way to find that out is to do one or two things. Do an echocardiograph, which is like a little ultrasound over your heart, so we can approximate the size of your left ventricle and guess how much blood it's pumping out per beat, or we can kill you in autopsy here. Not really a good answer, is it? Because I don't think it's worth sacrificing your life to find out what your stroke volume is. Kind of defeats the object. But those are the kind of things that we're looking at and the relationship between the three. So you need to know the definition of all three, and you need to know the relationship, i.e. this equation. Now here's a little 2 marker. Now sometimes we'll ask for definitions, cardiac output, stroke volume, as we've said. What is the relationship between them? That equation that we've just looked at. And sometimes they ask this one as a little follow-up. Sometimes they'll just ask it on their own. What effect does training have on resting cardiac output and stroke volume? Now this question, when it says training, here, it means a period of training. 6 weeks, 6 months, something like that. So you've taken part in a training program. But the key word, the absolute key word in this question here is resting, right? Whilst you are sat watching TV, whilst you are laid in bed, whilst you are chilling out, that's what it means. Now here's the hardest thing to get your head around. Just stick with me on this, trust me on this one, okay? We've just seen, typically, an average person, when they are sat relaxing, they will have a cardiac output of around about 5 litres per minute, okay? And I'll just put 5 litres per minute there, okay? Now here's my point to you. If I was to send you altitude training with Mo Farah for 6 months, and before you went, I measured your cardiac output whilst you were sat down, and your cardiac output was 5 litres a minute, I then send you off with Mo, and you do 6 months of the most intense altitude training you've ever undergone in your life, okay? And you come back and you sit down with me, you're a hell of a lot fitter, okay? But you sit down next to me and I measure your cardiac output, what do you reckon it will be? Well, the answer is it will be exactly the same. It will be 5 litres per minute. Why? Because you are resting. You've got fitter, but the point is, when you are sat chilled out, your heart doesn't have to pump any more blood around your body per minute. So it doesn't. Why make more work for yourself? Think of it that way. So the point here is, at rest, cardiac output remains the same. Whether you are super fit or super unfit, when you are at rest, cardiac output remains the same. It does not change. Okay? So you might be getting confused. So what was the point in you sending me high altitude training with Mo Farah for 6 months if it hasn't changed? Remember, that doesn't have to change, so it won't. Your exercising cardiac output, the amount of blood your heart can pump out per minute when you are exercising, that will have gone through the roof. That will have massively increased because you're now much fitter than what you were. But the key thing there is, at rest, it won't change this. It will stay the same. It won't change. That's the key thing. But what will have changed, okay? Remember, this question, if we quickly go back to it, is asking what effect does training have on resting cardiac output and stroke volume? We've picked up one of the two by saying at rest, cardiac output remains the same. But what's the second mark? Well, the second mark, and I'll just change the colour of my pen, is this. Stroke volume will have increased. And why will it have increased? Due to something called cardiac, and people pronounce this differently, hypertrophy, hypertrophy. Hypertrophy, hypertrophy, a muscle has got bigger. So with it being cardiac hypertrophy, the heart tissue, the heart muscle itself has got bigger. Right? Confused? Don't be. I'll show you what I mean. There's our equation that we've been looking at today. Cardiac output equals stroke volume times heart rate. I've sent you altitude training with Mo Farah. 6 months down the line, your resting cardiac output has stayed the same. And I'll do a horizontal arrow there to reflect the fact it's not gone up, it's not gone down, it's stayed the same. But I've just said to you, your stroke volume will have increased. Why? Because your heart is now bigger and stronger than it's ever been before, so you will have undergone cardiac hypertrophy. If your heart is now bigger and stronger, it can now pump out more blood per beat, which, if you remember, that's what stroke volume is, the volume of blood you can pump out per beat. How do we know this has happened? Think about it. What's one of the key ways we assess your fitness and your health is by looking at your heart rate. And when do we know that you are fit and healthy? When your heart rate at rest is decreased. Who are the fittest among you in the class, in the group? The ones who've got a heart rate of less than 60 beats a minute, of less than 70 beats a minute. Those of you who've got a very low resting heart rate, we classify as the fitter people. People who've got a very high resting heart rate, 80 plus, 90 plus. Some people even have a resting heart rate of over 100 beats a minute. That's a very bad sign, very unfit. Just think about that for a minute. Review that equation. Your resting cardiac output has stayed the same, but because you are fitter, because you've done this 6 months altitude training, the size and strength of your heart has increased, so it can pump out more blood per beat. Because it can pump out more blood per beat, it doesn't have to beat as often. And that's why a low resting heart rate is an indicator of a very high fitness level. So review that question. What effect does training have on resting cardiac output and stroke volume? 2 marks. Number 1, cardiac output at rest will remain the same. However, because you are fitter and healthier following that period of training, your stroke volume will have increased because your heart is bigger and stronger. So if your stroke volume has increased and your cardiac output has stayed the same, that must mean that your heart rate has decreased. One's gone up, one's gone down, and that's meant that the cardiac output value hasn't changed. Okay? Watch that as many times as you can. Think about it. Think about the science behind it. Right, finally, you're doing really, really well on this. If you're grasping it, finally, here's the very crude table that I've just quickly drawn. And as you can see at the top, it says what happens during exercise. And then down the left-hand column, we've got 3 terms that we're familiar with: heart rate, stroke volume, cardiac output, and one that you might not be familiar with, venous return. Now, here's the thing. Venous comes from vein, or vein comes from Venus, not Venus planet, it's O-U-S, okay? So Venus meaning the vein, and return. Now, what you might know, what you maybe should know, is that veins, why do we call a blood vessel a vein as opposed to an artery or a capillary? Veins carry blood back to the heart. All veins carry blood towards the heart, okay? So venous return, really, really quickly, is the return of blood to the heart. This is always happening. Blood is being pumped out of your heart to the muscles, to the organs, dropping off its oxygen, picking up any carbon dioxide, and then it's making its way back to the heart. Okay? That is called venous return. It's returning to the heart in the veins. So there's a very, very quick, brief definition of that. We're going to look more about venous return when we look at the vascular system, when we look at the blood vessels and things like that. But you just need a very quick definition of that. Now, what happens to each of these during exercise? Heart rate obviously increases. More BPM, more beats per minute. As you exercise, heart rate increases. We know that. Now, what you might not know is this. Stroke volume also increases. Now, remember, at rest, your heart was maybe pumping out, we said on average, 70 millilitres of blood per beat. That can actually increase, and that will increase. So during exercise, we'll get up to, maybe 100 mils. So we can actually pump out more blood out of our heart per beat, okay? Now, obviously, it doesn't take a brainiac to figure this out. Cardiac output equals stroke volume times heart rate. If heart rate has increased and stroke volume has increased, well, surprise, surprise, during exercise, cardiac output will also increase, okay? Now, remember, the last slide was about when you are at rest. This is about during exercise. This is a much more straightforward one. When I am running, when I am cycling, when I am swimming, heart rate is going to increase, stroke volume is going to increase, and cardiac output is going to increase. It's the one that's at rest that's the tricky one to get your head around, and that's where you've just got to go, hang on, take my time on this. Even though I'm fitter, maybe following a period of training, just because I'm fitter doesn't mean my heart is now going to pump out more blood per minute when I'm at rest. There's no demand for it, so why do it? That's just going to stay the same at rest. Right, what I'm just going to quickly do to finally finish this off is look at this, because this is the one that they can ask and often ask a separate question on themselves. Okay, as you've got at the top there, increased stroke volume during exercise. This has its own specific name, and this is known as Starlings Law of the Heart. They can and often do ask you about this separately. What is Starlings Law of the Heart? Well, if they haven't already said it in the question, you will get a mark for saying that it is an increase in stroke volume during exercise. Now, this is the thing that the people often struggle with the most, right? There is the worst diagram in the world of a heart, and as you know, it's split into chambers, and this is my right side, even though I'm looking and it's on my left, and there's my left side. Atria, ventricle, ventricle. We are talking about, remember, stroke volume, we're talking typically about this chamber here. We can say stroke volume is the volume of blood pumped out of the heart. That is absolutely fine, but remember, if you want to be even more technical, it's the volume of blood pumped out of the left ventricle. So what we're basically saying, and what Starling showed, is that during exercise, the amount of blood pumped out of that ventricle increases. Now, what people struggle with is, how does it do that? My heart is its size now. If I was to suddenly go on a run, how has my heart got bigger between now and going on a run? Yeah, it'll get bigger over time, over months and years of training, but it can't just get bigger like that, can it? Well, actually, think about it, it can. What is your heart? It's a muscle. What do muscles do? They stretch. So what is Starling's Law of the Heart? Well, Starling's Law of the Heart states this, that during exercise, venous return, so this is that term from the previous slide, venous return increases. So the volume of blood flowing back to the heart goes up. That makes sense. You're producing more carbon dioxide. You need to get rid of it. So you need to get it back to the heart very, very quickly so you can then get it to the lungs to drop off the CO2 so it can then pick up fresh oxygen. So this blood is now pouring back into the heart much quicker. Now, what does this do? As I've just said, your heart is a muscle. So the heart will fill with blood quicker. And what will that do? It will stretch more. Those of you thinking back to those long summer days, get a water balloon, stick it under the tap, turn the tap on a bit, it'll fill a bit. Crank the tap on full blast, that water balloon will expand very, very quickly. It'll go on a full stretch. That's exactly the same as the heart. Okay, so now that the venous return has increased, the heart will fill with blood quicker and stretch more. So what are we then saying? The chambers, including the left ventricle, will hold more blood. Okay? And then finally, to finish this off, Starlings Law of the heart, it's holding more blood, but think about any muscle. If you stretch it, if you stretch a muscle, think about an elastic band. If I stretch an elastic band a little bit, it'll twang a little bit. If I put the elastic band on full stretch and let go of it, it will twang with much more force. So the more I stretch a muscle, the more powerfully it will contract. So venous return increases, the heart will fill with blood quicker and stretch more, the chambers will hold more blood, and there, as a result, the heart will produce a more powerful, and I'm going to run out of space here unfortunately, so I'm going to try and squeeze it under there, a more powerful contraction. And if it's holding more blood, the chamber, if that left ventricle there, as well as all the other three, but that's the one we're interested in, can hold more blood, and it produces a more powerful contraction, how much blood is it going to pump out per beat? More. And that is your increased stroke volume. The scientist, the physiologist who figured out was Starling, so it's known as Starling's Law of the heart, okay? Have a go at the questions in your book related to that. Read the information in the passages just before it as well, okay? If in doubt, watch it again. Watch it as many times as you need to try and grasp these things. Maybe even watch this video in parts again in the future so it's not too much information in one go. Good luck with it all, folks.